In this video, we're going to be talking about probability and what kind of questions we see related to that on the ACT. By definition, probability is the likelihood of some event occurring. Using a word from that definition, event, that is something when you have one or more outcomes. So when we're talking about like tossing a coin, is it heads or tail? Each one of those tosses is an event. Throwing a dice. What do you roll when you throw a dice? That is an event. Things like that. So our probability is the likelihood of having some particular event. It's a value between 0 and 1. And 0 means that it doesn't happen. It absolutely doesn't happen, with 1 being it absolutely happens. You may see these as percents, 0 and 100%, but if we're using decimal numbers, we're talking about 0 and 1. And the likelihood is going to take place probably somewhere in between there when we're talking about questions that we'll see on the ACT. By definition, we also think of probability as part over a whole, a fractional portion. And we can talk about the number of times some event occurs divided by the number of all events that are occurring. So another example is a batting average. If we oftentimes will say somebody's batting average is 300, so what does that 300 batting average mean? It's actually a decimal, and it means that the number of hits divided by the number of times at bat comes out to be 0.3. Or they're at a 30% batting average. They hit the ball 30% of the time. And like we've already kind of touched on here, we can express probability as a percent, a decimal, or even as a fraction. So I want you to be familiar with all three types of expressions for probability. A couple of other definitions that come into play. We see these sometimes show up in questions. An independent event. Event, remember, we said has some kind of outcome. If it's independent, it's an event that is not affected by other events. For example, a coin toss. I can toss a coin, say it's on heads. I will toss it again, and whatever that second toss is, it is not affected by what I tossed the first time. Those are independent events. A lot of times we'll make use of Venn diagrams to look at probability and when we're talking about different events. So this is an example of a Venn diagram. You should be familiar with that. You've probably seen it before. May not have known about the name. We have two different events. First of all, we have the event A on the left, and then we have event B on the right. Those two events, notice they are overlapping. And so we can do some probabilities based on this Venn diagram. This is a great thing whether it's on your test, if they actually have it drawn. A lot of times I will draw out Venn diagrams when I'm working with probability. We can find things like the probability of A and B, the probability that both of these events occur. And let's look at what that means on the Venn diagram. So that's the probability that both of these occur, and that's where that overlap is, where we have that we've scribbled in. That's an overlap area. Well, how do we calculate that? We'll get that from the probability of A times the probability of B. That's what we're going to use to find the probability of A and B. Now, what about another area that we could look at? What about the probability of A or B? Either A can occur or B can occur. Well, let's look. Here we have the probability of A that's shown up in red, and then we have the probability of B that shows up in blue. Well, we can't just add up these two, because if you noticed when we looked at the red and the blue, we had that overlap area we counted twice. So from the probability of A plus the probability of B, we're going to need to subtract out that one of those overlap areas because we double counted. So we're going to subtract out the probability of A and B. And we had that from we can use the probability of A times the probability of B. You could substitute that in if you were actually having to find those numbers. Another definition let's talk about with probability is being mutually exclusive. And what that means is if events are mutually exclusive, they cannot happen at the same time. It's a yes or no, binary, one or the other, not both. And here's what the Venn diagram looks like for mutually exclusive events. There is no overlap. It's either A or B. Let's look at some things about mutually exclusive events. So when we say that there's no overlap, that means the probability of A and B equals 0. They never overlap. There's no probability of these events both occurring. We can look at the probability of A or B, in this case as being just the probability of A plus the probability of B. That's it. We don't have to subtract anything here because there's no overlap. We'll just add those together. If A and B are the only two possibilities of outcomes, then the probability of A or B should equal 1. We could also have dependent events. If we had independent events where an event is not affected by any other event, a dependent event is where you're going to have an event that is affected by other events. And we usually call this conditional probability. You can think about this drawing from a deck of cards without replacement. Our sample size is changing. It's going to decrease. If we don't put a card back after we draw one, that's a dependent event. So here's an example. We're talking about marbles here. We have a jar of 6 red marbles, 4 black marbles. 2 marbles are drawn without replacement. What is the probability that both marbles are black? So let's take a look. We have an event A, we'll call it, that the first marble is black, and event B is the second marble is black. So we can look at the probability of A. We have 4 black marbles out of the 10, so we have a 4/10 probability of drawing a black. Now we only have 9 marbles left in the jar, and only 3 of those which are black. So the probability of B, the second marble being black, given A, that the first one was black, we have this notation here of the probability B with a line down A. That means conditional probability. The probability of B given A is 3/9. So we want to look at the probability of A and B, both of these occurring. We're just going to multiply these two together, and we get 2/15. Most ACT questions related to probability, you're going to have to get some data from a table, a graph, or a chart. It may involve tossing coins, rolling dice, drawing objects from a bag or from a deck of cards, so be familiar with the different possibilities that you could have in these cases. And also being familiar, again, with permutations and combinations. We have a video that you can watch on those specifically because sometimes they come into play with probability. But we also want to come back to our definition of probability being the part over the whole. So here's an example problem to take a look at. Pause the video here and come back and we'll work it together. It says Chris developed a random code generator that generates a code made up of 5 unique alphabetical letters. What is the probability of generating the code HTZOW? So we're looking for 5 unique letters. And so we want to keep in mind there's 26 letters in the alphabet. And when we first look at the first letter, H, the probability of getting an H is 1/26. We're looking for probability here. Now we have 25 letters left because, again, it's unique. So the probability of generating a T is going to be 1/25. We'll move on to the next letter of Z, and we have 24 letters to choose from there. Now it's 1/24. And we'll continue that same process with O and W. And so that's going to lead us to answer choice A. We have 1/26 times 25 times 24 times 23 times 22. Keep that in mind. It is answer choice A as opposed to answer choice D. D gives us the total number of options, but we're looking for a probability.